with the webinar, so thank you everybody for attending, both online and in the room. So today what we're going to be talking about is some new data that we are proposing at ARB to include into our next evaluation of the CHIT model, the California Hydrogen Infrastructure Tool. I will quickly say that I'm going to give a little bit of an overview of what the CHIT tool is in general, but there is a webinar from 2015 online that has a full kind of in-depth discussion of every aspect of CHIT and all the data inputs that were utilized. All those data inputs have been utilized the past, I guess, 2 years for our annual June evaluations, the June ABA reports, as you may be familiar with them, as well as for the most recent GFO 15605 that for the Energy Commission's grant solicitation. So what we're talking about today is looking at new data that stakeholders had indicated they were interested in being possibly included into our CHIT evaluations and to look at whether or not we should put that into the tool itself and implement that from this point on. So again, the purpose today I really want to emphasize is to review this data and to review the concepts of how we might put it into CHIT and how we might use it in CHIT. And the data in particular is traffic intensity data. So when we provided the CHIT 2015 webinar, one of the comments that came out of that webinar, and actually even aside from that webinar, was that CHIT looks to place stations only where the first adopters might live. But an equally valid and possibly equally important factor is where do people drive. You want to look at driving patterns, driving intensity, traffic intensity. And so at the time, there was limited data available, and so we went ahead and tried to find data again, did not find available data, and instead we developed a simulated traffic volume data set. And so since it's a simulated traffic volume data set, we feel that we need to have extra stakeholder oversight, a little bit more independent review to make sure that this is something we actually want to go ahead with. So what I'll be doing today is covering a quick review of CHIT, the need for this traffic volume data set. We'll discuss how we came up with this data set and actually do a little bit of looking into what it actually shows, some of the validation we were able to complete. As I mentioned, there isn't a lot of publicly available data that's in a very complete form to be in the first place, so it's kind of we're using a limited set of data to be able to validate it, and then how we might use this in CHIT, how we might actually use this as we've developed CHIT to date, which is for kind of the core market-based stations, but also how might we be able to use this data to make suggestions about where connector stations need to be for long-distance travel. That's something that so far we have not been able to do with CHIT, and so we're looking at maybe whether or not this data could enable that. And then finally, some additions that we could implement we haven't done yet with these data, but additions that we could implement and different options for that. And then I do want to emphasize at the end, or even throughout, open discussion and feedback is highly encouraged for this. So if for those on the webinar, I believe we're going to have you muted, but if at any time you want to ask a question, please click the raise hand button or type your question into the chat box. My colleague Jeffrey Lideker is monitoring the webinar as I'm speaking, so he'll keep an eye on it, and we'll try to get to your questions as quickly and efficiently as we can. So I'll begin with the CHIT review. So we developed CHIT as part of a two-tool, actually part of 2 tools at ARB to help us complete our requirements under Assembly Bill 8. So Assembly Bill 8 is the enabling legislation that actually provides the funding for the hydrogen fueling stations through the Energy Commission, but it also comes with it a series of analysis and reporting requirements. And part of ARB's reporting requirements is what you see in the June reports. It's where we have to make recommendations to the Energy Commission about where stations should be built and what kind of specifications should they have. And that includes the capacities of the stations as well as their technical capabilities. And we make these decisions that are informed by where we think the market's going to be, where auto manufacturers think the market's going to be, and where we're actually seeing the vehicles being registered. So the two tools that we developed were CHIT and CHAT. CHAT is actually just a database. It helps us keep track of auto manufacturer survey responses. Every year we send a survey to the auto manufacturers. They're required to provide the fuel cell vehicle deployment plans for the next 3 model years. We get that information each year for those 3 years and divided by county. Beyond that, we actually also ask for optional data for the next 3, for model years 4 through 6 in the future. And in the past, that's been more limited, but we're starting to expand that also into a per year and per county piece of information, piece of data. So we use CHAT to keep track of that, keep track of the stations, keep track of their status, and be able to make a sort of larger granular kind of analyses on the capacity available, the demand in different counties, et cetera. We use CHIT to do more detailed analyses, to look at where actually within those counties are those vehicles likely to go based on where the early adopter markets are. And then also looking at where those early adopter markets are, how does that compare to the service level provided by the existing and funded stations? And so that is what CHIT does. CHIT kind of does this overlay of the market, the expected market, and what the coverage is provided by the stations. So those are these two portions you can see in the lower left where we have station coverage and the market indicators kind of give us a way of evaluating what the localized targets for further funding are. And so as I mentioned, we utilize this in our AB8 reports every June. And in this last GFO, it was actually part of the awarding process. One of the factors in the GFO scoring did include analysis from CHIT. So based on the need for coverage in an area and based on the need for capacity in an area, that went into the determination of which stations were the appropriate ones to award. So to kind of look at the big picture here, what we're really trying to do is plan the infrastructure placement appropriately for upcoming fuel cell vehicle releases. That's the main goal. That's what we want to finally get to. And the way we view this as is there are 3 steps to that. You first have to identify the market. You have to then evaluate what your current infrastructure is. And then you have to prioritize year by year for what the parts of the market that don't have the right amount of coverage, right? And so in this first year, you might decide that stations need to be somewhere in these first green bubbles, and you might get some of those, you might not. And then so you add new areas in the next year, or you might keep some of the same areas. It depends on how well the degree of and intensity of the coverage matches the degree and intensity of the market. And so coverage is really a central theme to all of our analyses. In concept, it's a representation of convenient access to fueling stations. Essentially what we want to do is make sure that in a full build-out scenario, obviously, no driver should have to go any further now than they do out of their way to get to a gas station in order to fuel up their hydrogen fuel vehicle. In the early market, we have to be a little bit more targeted and be able to meet the needs of those first adopters because we only have so many stations that we can put out there through AB8. So we're trying to find the best locations for these 100 stations that we're funding through AB8, 100 or so. Coverage is usually defined in terms of time. So you want to be within, say, a 6-minute drive of a fueling station in order to say that you have really convenient coverage, that's a good benchmark, that you are close enough to the fueling station that it is conveniently accessible to you. And it can be kind of conceptualized as either, yes, I'm within 6 minutes of a hydrogen station, or I'm not. Or you can actually look at degrees of coverage, which is what we actually do in CHIT. We look at, well, somebody who's a minute away from a station has a lot more convenience than somebody who's 15 minutes away from the station or even 6 minutes away from the station. And somebody who has one station 3 minutes away and another 9 minutes away has more convenient access than somebody who has one station 3 minutes away, but their next one is half an hour away, right? So we actually look in CHIT at overlapping coverage from different stations at different degrees and look at kind of what is the combined sum total of that for every location in the state. And so the concept here is that well-planned coverage increases consumer confidence, which then increases adoption of the vehicles. Yeah, we have a question?
You were soliciting for interruptions.
Yeah.
I have a question from Zach Thompson. Does ARB share the chat data from auto manufacturers? ?
So we do not share the individual auto manufacturer responses. That's confidential business information. We do utilize those data in our reports out every year in June. And so what we do is we aggregate all the auto manufacturers' responses within each county into a single number. So we do not provide individual auto manufacturer numbers, but we do provide the aggregate values. One or a couple of caveats on that are that there are a couple of adjustments because we receive data in model year, but we report out in calendar year. So there's an assumption about the correlation between those two. And there was one other thing, but I am blanking on it right now. But if I remember it, I'll mention it later. All of that information actually is reported, though, in the June report. So any of the assumptions that go into the numbers that we report out, you can find them in the June report. Is there another question? Or? Okay. So the coverage algorithm that we developed, as I mentioned, it's more informative than a binary yes or no. It allows for looking at degrees of coverage, and it estimates the combined coverage provided by multiple stations that may be reachable within various drive times. So you can see, I admit this is actually an older map currently on the screen from when we first developed CHIT. So there are some stations included in this analysis that have moved. But if we concentrate kind of on the area around San Jose, there are about 4 or 5 stations in this area. And you can see how proximity to the different stations and different numbers of the stations changes how intense or how high of a degree of coverage or how high of a degree of convenience you have in smaller individual neighborhoods within that region. Whereas if you go out to Livermore, there's literally no coverage. We assume that 15 minutes is the extent of convenience for drivers. But if you're in San Mateo, you have kind of a lower degree of coverage because there's only 1 or 2 stations in that region, or at least there were as of the time of this analysis. And so CHIT itself is really designed as a planning tool, and that came out of the need that we had for AB8. It's a planning tool that's intended to provide general areas of direction for needed infrastructure. One thing that we want to emphasize is that CHIT is not intended to be the tool that tells you you should put a hydrogen station at this exact corner of this intersection. CHIT is meant to provide flexibility. It's working within this program that has solicitations and applications for grant funding or any other kind of funding that comes through the program. And so we want to provide flexibility to those who want to apply for that money. And so CHIT is not meant to be prescriptive in terms of these are the exact 100 locations in the state that we need to get a hydrogen station at. And in reality, that doesn't serve a lot of good even if we could, because we do have to recognize that even if we think those are the 100 locations, those may not be the 100 locations where there are station operators, station owners who want a hydrogen station, where the permitting is easy, et cetera, et cetera. So there are a lot of flexibilities that we want to allow. This is just to give a general direction. And so it evaluates the relative need for hydrogen based on a gap analysis between the projected market and the current infrastructure. So up on the left is the market assessment, and that's based on the home locations of the first adopters. And we try to locate the first adopters according to a number of metrics that I'll discuss in a few slides. And in this image, a darker shade of blue means a higher concentration of likely first adopters. On the right in the purple is the coverage assessment. And so that's what I showed on the previous slide, and actually this one is updated. where you can see there's not a lot of coverage actually leading up to the peninsula. And so a darker shade of purple means more, higher degree of coverage, greater convenience for any early adopter who might be in that region who would buy a fuel cell vehicle. And so you overlay the two, and where the two don't match in terms of intensity, that's where you need a hydrogen station more likely. So you can see that that in San Francisco, as of the time of this evaluation, there was a high concentration of likely early adopters, but no hydrogen station coverage, no fueling coverage. And so San Francisco has the greatest disparity actually across the state in those two factors. And so that's where we get to the conclusion that San Francisco is actually where we needed the most hydrogen stations. That was the area that needed the most coverage. And then, as it turned out, we actually also use this data for determining the capacity that's needed in each area based on the auto manufacturer survey volumes. And we found that it's also the area that needs the highest capacity of new hydrogen fueling stations. So in this bottom map, the red is the highest need for a new station based on coverage and convenience, and the deep blue is where you don't really have a high need at all. So some of the indicators that we use to look at the early adopter market, we look at financial indicators. We do look at an indicator for educational attainment. We look at some green vehicle adoption trends, though in particular we limit this to green vehicles that do not require a change of fueling behavior, because that's part of the whole idea behind the fuel cell vehicle and hydrogen infrastructure. And so we are looking at, in particular, plug-in hybrid and hybrid electric vehicle adoption rates during their own specific first adopter years. And then other general vehicle trends in terms of registration. And we kind of overlay all those, and we give each of those factors kind of a weight, and you sum them up, and you get to a heat map across the state. And that heat map back in 2015, I believe, looked like this. And the actual equation itself and the weightings you can see are on this slide. So basically the coverage times the market, that's how you get that overlay. And our coverage is defined by equal parts of coverage provided by the existing stations and then coverage that could be provided if you put a station nearby. So if you want more details about that, that was discussed in the actual 2015 CHIT webinar. You could say it is very highly correlated essentially to population density. So you want to look at, if I'm going to put a new station somewhere and I have a high population density, that means I'm possibly going to serve more people, as long as it's also a high early adopter metric area. And then for defining the early adopters, again, we look at these financial indicators, the green vehicle and education indicators. And the financial indicators are based on income, luxury vehicle adoption, and MSRP of registered vehicles. And I'll also say that we did not come up with all of these on our own. A lot of these are actually shared with similar tools that you might find in the literature, such as the SARA tool, the SARA model in particular from NREL. They have a number of these features in them. Some of the things that we did add are kind of the MSRP range and the plug-in and hybrid vehicle adoption rate in particular for our work. And so in terms of actually what is CHIT, it's mostly a set of custom tools built into ArcGIS or built in ArcGIS Model Builder. The full model, all the tools, all of the input data we used in 2015, and all of the actual output resulting data from the 2015 analysis are all online on ARB's website to download. So if you go to arb.ca.gov/hydrogen, there's a link on that page to an infrastructure analysis subpage, and you can find everything about CHIT there. You can also find the previous webinar. After this webinar will be posted, and any future releases of the tool will be posted there as well. And so these are just tools that are built with ArcGIS. It does require an ArcGIS license to run it, but we did make an effort to not utilize any function that requires elevated licenses. in ArcGIS. So you can run everything with just a basic license. And you may actually also be able to run it with open source GIS software. We have not tested that, but we're aware that you may be able to do that, may be able to accomplish that. And so, as a reminder, there were some guiding principles for developing CHIT that we feel we have to follow for every piece of data that we want to include, and for the entire method. So, the first principle, these are abbreviated versions, but essentially CHIT is a relative assessment. So CHIT looks at where is the highest market potential and where is the highest coverage, and do those match, right? It does not necessarily tell you that you need 16 stations in this area in particular to get the coverage that you need for this market. It tells you that your market and your coverage are out of sync, but it doesn't necessarily tell you absolute values. CHIT is a statewide assessment, and important to that is that it's a statewide assessment that's completed equivalently at every location in the state. CHIT assesses only the first adopter market. The fuel cell vehicle market can be estimated by the relative distribution of multiple demographic indicators. You saw that on the previous slides. We're essentially estimating where the first adopter market for fuel cell vehicles resides based on these demographic indicators. Accurate assessment of coverage depends on detailed roadway data. If you revisit the 2015 webinar, we spent a good deal of time discussing how we generated a finely detailed set of roadway data that allows us to evaluate travel speeds even on lower classification roads that was kind of not really utilized in previous models. And so that helps us really get a better sense, a more accurate sense for how far can you go from a station and still be within 1 minute, within 6 minutes, and not have too large of an estimation for service area and for coverage. Coverage matches the market when it provides convenient fueling access near the driver's homes. So that was an actual fundamental principle of how we first developed CHIT. And it must be a tool that can be shared with the public. So every input piece of data has to be something that we can share. It cannot be something that we bought. It cannot be something that's proprietary. And today, what we're basically doing is we're reconsidering principles 4 and 6. We're thinking about, okay, do we need to change what we're doing in terms of the definition of what the market really is or what coverage really needs to be? So before we go into getting to that point, do we have any questions in the room or online? No? Yeah, Chris, can you use the, so press the button to, yeah, there you go, you're on. No, let go of it. There you go.
Chris Jenks, Energy Commission. I'm just wondering, as I listen to this presentation, if you've looked as each station has become open retail to find out how well CHIT was able to predict the volume at that station that it actually has.
So the first stations that were actually selected and informed by CHIT are the ones that were just awarded. And the ones that were awarded previously, we're just now starting to get that throughput data from those stations, right, through the NREL tool. For those who are not familiar, every awarded station has to provide data back to NREL, and some of the data that is included is the throughput at the station. We do also have meetings with and hear from the station developers themselves and hear of anecdotes of certain stations running out of hydrogen fuel very early or already at some of their stations, so that they experience days where maybe they at 80% utilization or totally run out of the fuel at their station. I have not looked at whether or not those are particularly high market area locations. From what I can remember of some of the anecdotal data I have heard, I'm not surprised by some of those stations, but I would have to look at, I think we kind of need more data to really be able to figure out that correlation. Yeah. Okay. So as I had mentioned, our big picture is identifying the market, trying to figure out what does our current infrastructure actually provide, and then where is that gap, right? And what we're really reconsidering today is, well, we previously thought, okay, we're going to define the market only as where the first adopters live. But stakeholders said, well, the market's actually mobile, so you actually have to also consider where fuel cell vehicles might be driving. That could be part of the equation too. And so we're going to look at, well, do we have sufficient data about the driving patterns? And if we did, how could we integrate this? So what that means is that these are the full text versions of what we had previously used as principles 4 and 6. So coverage matches the market when it provides convenient fueling access near fuel cell drivers' homes. We might add coverage is also defined by proximity to commonly traveled routes, right? So we might want to look at that. And then also, instead of identification of the fuel cell vehicle market can be estimated by consideration of the relative distribution of multiple demographic indicators, we might need to clarify that identification of the fuel cell vehicle owner market is estimated by those indicators, but the total fueling market potential is actually estimated by that and the commonly traveled routes, right? So if maybe you have a neighborhood that's near a commonly traveled route, that might give you a better picture of the total fueling market potential in that area versus if you're only looking at where the first adopter markets live, right? So back in 2015, we actually had tried to include this. We utilized the same data source that we had used for our traffic speed and our traffic speed data, and looked at the volume information that was available in that data set. And what we found was it was not actually very informative equivalently across the state. There were some areas where there were slight differences in the traffic volume predicted or provided in the data, but there were large areas, like as you can see in San Diego, where essentially it said that the traffic is the same everywhere. That there wasn't really you couldn't really identify any like main chunks of traffic, right? You couldn't identify those main travel patterns. So even though the ITN Tiger, that's the data set that we developed for the speeds, even though that was good for speed, it really wasn't good for volume in all areas. And really, an explicit and direct consideration of traffic patterns requires knowing something about origin destination, the origin of where people start driving and where they end up, and in order to really understand what those traffic patterns are and what traffic intensity might be on different roads throughout the state. We did also investigate other data sources like the California Household Travel Survey, CalTrans Annual Average Daily Traffic, or CHAPIS, and usually the problem with these was that Principle 5 was not fulfilled. We didn't have really accurate, really finely detailed information, right? So what we're showing in this map is I think this is actually the CalTrans Annual Average Daily Traffic data points in the Bay Area. And while for the whole state there are 7,000 data points, and that sounds like a lot, in reality you have no information about your lower classification roads, your neighborhood roads, your roads that lead out to the highways. What you really have is mostly a lot of information about the major highways and maybe the second tier highways or second classification highways. And so we can't really use that information very well when we're trying to look at full traffic patterns, and we wouldn't have data then that is equivalent to the detail and precision that we have for the coverage data and for the other information that we utilize in CHIT. Is there a question?
Okay, we have another question online.
Okay.
Does CHIT currently use radius from a target home or mapped path?
So CHIT performs what's called a service area calculation around every station in order to determine the coverage from the station. So what we do is we actually calculate the individual routes as you would drive on the street. So how far you could reach within 1 minute of a station, how far you could reach within 3, 6, 9, 12, and 15 minutes. So it's not just a mileage radius buffer, it is actually looking at the driven paths. That's it. Okay. So back in 2015, we were kind of at this impasse where we wanted to be able to look at this at least and consider looking at traffic data, but we couldn't find an open, freely available data set. We are aware that there are data sets out there that you can purchase, but we would then not be able to share that with the public because they'd be proprietary data sets. And so what we did is we looked into developing a simulation of the traffic. So the concept is if you had a sufficiently detailed street geometry and travel speed data, which is what we believe ITN Tiger provides to us, and the availability of origin destination for commutes, you may be able to do route simulation to kind of determine what is everybody's daily commute. But one major problem here, of course, is that simulated data then requires elevated scrutiny because this is not observed data. This is what we're trying to predict might be the traffic patterns throughout the state based on knowledge of where people's homes are and where their commute destinations are, or at least where they are reported to be. So one of the leads, one of the actual positive things that came out of the October 2015 webinar was a suggestion to look into what's called loads. This is from the, I believe it's from the census. It's the LEHD, which itself stands for Longitudinal Employer Household Dynamics, I believe is the D, Origin Destination Employment Statistics Dataset. So a really long name. But what it does is it provides pairs of home and work census blocks for all respondents. So basically any respondent says, I live at this address, I work at this address. And what's provided in the data from the census is the census block resolution of that. So we don't get door-to-door, but we get census block resolution. We also get with that actually the number of respondents who had that same actual pair of origin destination, which is actually not always just one person. There's sometimes multiple people who live on the same block and work on the same block. The census block resolution, of course, is not an exact street address, but it's still very good. We'll look at that in a second. It's still very good in most places. And ARB utilized the 2014 vintage. So over here on the left, we have the ITN Tiger data set. This is what we utilize in our calculation of coverage, and it's colored according to travel speed, basically. So these are the PM peak speeds. We utilize PM peak in all of our CHIT evaluations because within this ITN Tiger data set, it's actually slightly slower on average than the AM peak is. So essentially, in a way, we're looking at the worst case scenario for coverage by using PM peak. And then here in this table is some of the data after we did a little bit of processing where we get the geocode for the actual block group. We get its location in terms of coordinates on the map, or the blocks, I'm sorry, not the block groups, for each of the work and home points. So if we look at blocks, in these maps, the yellow dots are actually the locations of the blocks themselves. This is where, I guess maybe in the room you may not be able to see it as well, but on the top map is Sacramento. You can see kind of downtown on the left side and midtown towards the right. So these are the block centers. They're relatively good for downtown areas with large buildings that span, city blocks, right? You might have a number of individual addresses, but still you'd have a pretty good resolution there. It's less precise even in dense residential, but you wouldn't really change your results significantly. Even if you don't have the individual house door number, you're only on one side of the block versus another side of the block, so the error there is probably within, uncertainty at that point. And then in a rural setting, we have this map, this is kind of on the bottom, kind of east of Coalinga, and you can see in the bottom left, there's some development, but all the rest of it is essentially agricultural land. And you can see that there's especially sparse division of area into census blocks in the rural parts of the state. So in rural parts of the state, it might not be the best, but at the same time, you don't have high density, so you don't really have a lot of numbers of different addresses to really be looking at either. But we do need to be aware and recognize that it is less precise for door-to-door travel in the rural areas. Did you have a question? Okay. So in order to develop our data set, what we did is we essentially simulated every entry in the 2014 loads data file for California. So we geocode the census block centroids. So basically, in this GIS data, what you actually have is a polygon for every census block, but we take the center of that as a starting point, or as the point that identifies that census block. We get its X and Y coordinates on the map, and we load those into the network analyst, which allows us to be able to calculate the path. So we load every pair of an origin, which is the home, and a destination, which is work, and we load in our ITN Tiger roadway, and we ask ArcGIS through its network analyst to find us the path, the route, the quickest route between home and work with that travel speed data. So we're simulating the PM commute routes of all entries, and this inherently assumes a travel time optimization. So this is a limitation to this modeling. We do not know that this is the actual route. And the calculations do optimize for the least travel time for every single commuter, which may not be what they're actually doing in real life, right? But it's an assumption that we have to make for the model. So there were about 7.6 million records that represented almost 8.4 million different commutes in the data set available. And just for the techies, what we did is we executed this in ArcPython on 10 separate processors on 2 different computers because that was just what was available to us. And we would batch process 10,000 routes at a time. And so this took us 6 months. We essentially made 760 different files that each file has 10,000 simulated routes in it. And on the bottom, these are kind of our individual CPU times, and you can, if you took a look at this later on, you can easily see why we ended up with taking 6 months to do this. So that just gets us every single route, but that doesn't necessarily tell us, since every single route is divided into 760 different files, we don't yet have the information of the actual traffic intensity on every road. So what we have to do is we have to combine all that data from those 760 files. So here we did make one assumption. We noticed when we were simulating the data that we had a lot of really, really, really long routes. We had routes that spanned from Northern California to Southern California. And what we figured is some of the reporting is probably telecommuters reporting that, they live in Sacramento, but their home office, their headquarters is in LA, right? So what we did is we down selected our simulated routes to only those that had a 2-hour or less drive time. So that may be a little bit generous in terms of what's realistically a commute route, but we figured it wasn't overly generous, and it would capture probably almost everybody who's could potentially be driving that route. And then what we do is we have to spatially join all 760 of those files with our analysis grid and keep a running total of the number of commutes that basically pop up through each cell. This was a smaller computing effort. We were able to do this with a Python script in ArcMap natively, and took about 3 weeks. So I apologize in the room if you may be able to see it better on the screens in the back. So this is a sample of about 10,000 commutes, all these red lines on the map. And you can see from this map that we had some information that just we had some routes that just don't seem to make sense, right, as an actual drive. So what we did, and then here's zooming into the Bay to Sacramento area. And all of the blue lines here, this is the down selection of all the commutes that are less than or equal to 2 hours within that data set. So these are all those, this is what we actually counted as likely commutes from our simulation. So after we down selected to that 2-hour window, we came up with about 7.1 million commuters that we were simulating. And this is the statewide view of that map to kind of start giving you a little bit more sense of more localized information. Here is what the map looks like for San Francisco. Just as a side note, if you look really carefully, you can see these are actually hexagon cells. We're moving from a square grid cell for various reasons in our next use of CHIT, our next release of CHIT. But that will be covered in another webinar later on in the year. But you can see that essentially traffic coming over the Bay Bridge and traveling down towards the peninsula seems to be the highest concentration of traffic in this area according to this simulation, right? And then you can see additional areas of high use. And then these are 4 areas that I'm going to continuously refer to as we look at these data and as we look at some of the validation: Bay Area in general, San Diego, LA and Orange County, and Sacramento. And I realize that even at this zoom, it's still hard to see like individual patterns and recognize individual streets, but this is kind of give you a sense of, still, even in this data, in these data sets, or in this data set that we generated, you can still see that the highways are still, the major, traffic intensity. You're still your biggest carriers, but you can definitely see a lot more variation on the local streets and the lower classification streets than we were able to see with the data that we had from ITN and its volume characterization. So I'll leave these up here for about a minute to let people kind of take a look and investigate, especially since that's the point of today. So in the room, if you even want to get up and look at get close to the screens, that's fine. Yeah. And if you have any questions, now might be a good time to type them out or raise your hand, especially on the webinar. On the webinar, we can unmute you to let you ask your question through voice if you'd rather that than through typing out through chat. Yeah. Jane?
Hi, this is Jane Berner with the Energy Commission. So it sounds like the loads data set doesn't tell you anything about the current mode of travel that people use.
Yeah, absolutely right. I'm going to get to a slide. It might be the next slide, next pair of slides, that really outlines what the data set really tells you and what it doesn't, and that is absolutely one of the potential fallacies. We don't actually know what mode these people took to travel. And so you can see that this traffic across the Bay Bridge may actually be overestimated through this method, and we'll see that. I'll show you some of the validation data.
Chris Jenks, Energy Commission again. I'm just wondering if it was possible, or if you considered trying to get data from a company like Google or Waze that might have traffic volume and speed data already.
Right. To my knowledge, those data are not publicly freely available. There are APIs that could also tell you at a given time. If you're a developer of an app, you could use real-time data through that. But I am not aware of the availability of like authoritative, this is what we see as a travel pattern, over some period of time, et cetera. We could look into that again as well. There's also, at the very end, I'll mention there's another company that is coming out or has mentioned that they want to come out with some data available for, in particular, public agencies. So we'll see if that's actually available. Yeah, on the webinar.
Okay, we have a question online from Matt Forrest. Matt, you are unmuted. Matthew,
great.
Excuse me.
Andrew, I'm curious, regarding, this is Matt Forrest with Mercedes-Benz, regarding the CHIT score for the stations that were just awarded on the GFO solicitation. It seems like there was definitely some clustering going on in areas such as San Francisco. And I'm wondering if you've had a chance to compare how the CHIT score would differ between the first run of the GFO scoring and now adding in this traffic data. Do you get significantly different results? Are they slightly different, or are they nearly the same? Can you kind of characterize how adding this into CHIT affects the outcome of some of those awarded stations?
Right. So I have not looked at the awarded stations in particular. One complication to that is that the way we utilized CHIT for the awards in the GFO were that essentially all the stations were given their location and capacity score, and then all the stations were ranked, and the highest scoring station, considering not only the CHIT values but all the other factors that went into the evaluations, was actually selected and identified for funding. And then what we did is we took that station and added it to the network and then reevaluated every single other one of those stations and reevaluated how those stations compared to each other in CHIT and got a new score. And that is actually a reevaluation outside of me and outside of the CHIT tool. That's with the team. And so there's a little bit of an additional factor there that I can't capture completely by just doing a straight-up comparison of the CHIT values. That's not to say I can't do that. I can't obviously give the public an estimate of how those CHIT values would compare, but it may not give you the full story at the end of the day. And even though I haven't done that particular exercise of looking at the awards from the last GFO yet, we'll see in a few slides. I have some examples of just in general what is the effect of if we put this data layer in at different amounts of weighting compared to what we've been considering as coverage so far, or market so far.
Okay, thank you very much.
Yeah.
Okay, we have a couple more questions coming in online. I'm going to read the first one to you. It's a statement/question. There are a lot more people commuting more than 2 hours. We have a staff member commuting to Diamond Bar daily from San Diego, and several staff that don't fly and only drive to Sacramento for meetings. Plus, what about all the vacation trips?
Right. So we're definitely looking to try to capture only the commute travel, especially since that's the basis of the data set that we have. So vacation trips, et cetera, that's additional information that we're not trying to capture through this. We can try, but we have to identify a data set that we could utilize, and off the top of my head, I don't know what that data set would be. And in terms of the cutoff for the travel time for a commute, we still have all the base data. If one of the conclusions out of this webinar today is that we need to actually look at up to 3 hours of commute data, or of a commuter, possibly, we can redo essentially the overlay of summing every single commute within a cell. I will mention that within 2 hours captured a lot of the commuters. Again, we got 7.1 million commuters out of 8.4 that were in the original data set. And that drop-off is not only because of the 2-hour cutoff, but there also were, in every data set, there were a handful of routes that simply could not be calculated through the network analyst. So, you know, we might get a few more percentage points of inclusion, but I wouldn't expect it to be a huge difference at the end of the day. But if that is absolutely something that needs to be done, we can do it.
Okay, we've got more stuff coming in online here. Another question. Have you been able to cross-check the commuter heat map with gasoline volumes sold at existing retail stations?
I have not done that, and I don't believe that those data are actually public data. I do know that those data are tracked, but those are tracked, I believe, by the Energy Commission, and those are not freely or not publicly available to look at because that is confidential business information. I would also caution additionally that then you are looking at another indicator that is one step removed to try to validate the direct simulation of traffic patterns. I am going to show some validation in terms of comparing this data set to one of the limited data sets that I did mention earlier, the CalTrans data set. So we'll take a look at that in a minute, but yeah.
Okay, and now we have someone on the phone. Bud, are you there? You are unmuted. All right, we'll wait and see if Bud comes on the line. Bud will remain unmuted. They have their hand up. But there's also a question coming in from academia. Are traffic counts data available for use?
Are traffic counts data available for use? The data that we simulated?
I'm assuming that they want to use your data.
Right. So this data layer absolutely will be a publicly available data layer. We are currently working through the plans for a CHIT 2017 release that will likely come after the June report, and this could be included as a data layer. This could be included actually as a data layer whether or not we actually do implement it in our run of CHIT for our next June report. So we have made this. We can make it publicly available since it is based on publicly available information. The loads data set is public, and the ITN Tiger roadway network is public already through our CHIT release from 2015.
Bud, are you there? Okay, I'm going to mute Bud. You're going to have to put your hand back up if you still have that question. And we are done with those online.
All right. All right. So, okay. So actually, we'll go into a little bit of the validation that, oh, I don't know what that says. Okay. We'll go into a little bit of validation with the CalTrans data. So CalTrans maintains traffic census GIS data. In terms of what we want to do, it's actually kind of sparse, 7,000 data capture points across the state. I mean, in terms of what CalTrans needs to do and what a lot of planning agencies need to do, it's actually it's pretty good, pretty dense. But we want to know information on the lower classification roads, the neighborhood roadways, and that's simply not really in this data set. So it's concentrated on major highways and freeways, little data available on lower classification roads. But even though it's limited, we can still use it to explore the validity of this simulation where those data are available. So on the next slide, I'm going to show a map or with those same 4 areas, San Diego, Sacramento, LAOC, and the Bay Area. And in that map, there's a set of 3 circles, there's sets of 3 circles that are all on top of each other. The smallest circle is the CHIT simulation. The middle-sized circle behind it is the CalTrans data in the back direction, and the largest circle is the CalTrans data in the ahead direction. That's just the different directions of travel at each of the intersection points where CalTrans takes the reading. So the good thing about the CalTrans data is that this is actual observational data, right? So we have an observational data set, and even though it's sparse, we can at least check and compare what we got versus what the observed data are at those points. The CalTrans data are for the peak hour in 2014, so the vintage matches the vintage of the loads data that we utilized. One of the downsides of the CalTrans data is that it does not indicate whether it's the AM or PM peak. It's just giving you the peak travel during the day. And it could also not be what's during the traditionally considered AM or PM peak. And all data sets are normalized to their internal maximum. So we're looking at everything on a 0 to 1 range because what we're really looking at is kind of traffic intensity. So here you can see again, I'll say it again, in each of these circles, there's actually 3 circles, 3 rings. The center circle is our CHIT simulation. The middle circle is the back direction, and the large circle is the ahead direction. It's in that order because there was the most agreement between the CHIT simulation and the back direction. The back and the ahead direction don't have the same values because they're different directions of travel and at a different time of day or maybe even the same time of day, you don't know, and they could be just, you know, indicative of different travel patterns at different times of day. But what we're looking at here is, you can see there are a lot of these data points, especially in Sacramento, San Diego, and some of the sparser areas. The center circle, the CHIT simulation, matches essentially almost exactly or exactly with the back direction from the CalTrans data. In fact, there actually seems to be a lot more difference between the back direction and the head direction in the CalTrans data than there does between the CHIT simulation and either of those, right? So we're going to explore this a little bit more thoroughly, but this is just to give you a sense of, these are the essentially three data points we have at each one of these locations. And so here what we're plotting is the minimum error. So we're comparing CHIT simulation to the back direction, and we're comparing this simulation to the head direction, and we're picking which one of those gives us the least error, because we're assuming that then that means it's the most agreement between our simulation and the observed data. So blue is low error, and red is the highest error. And if I get rid of kind of the two lowest error sets, so everything where there's 20-point difference or less, then this is what we have. So the error where and remember, everything's on a kind of an intensity scale, a normalized 0 to 1. So everything that is left on the screen in terms of the dots is anywhere where the difference between our simulation and the observed traffic data is greater than 0.2, right, on a scale of 0 to 1. And that's only 100 points out of the 7,000 across the state. Anything greater than 0.3 difference is only 40 locations across the state. So this pie chart in the center, it's in the same color as the scale on the previous slide, but where you can see that, you know, you take out the dark blue and you take out that turquoise-ish color that's after it, and there's very few locations across the state where there seems to be significant error. Actually, as Jane mentioned earlier, you can see that it looks like that travel across the Bay Bridge might actually be overestimated by our simulation method, and very likely because our simulation method is assuming all those commuters are traveling by vehicle when they're probably, especially in the Bay Area, traveling by BART. Yeah. Thanks. So this is kind of a view towards the absolute difference between what we simulated and what is actually in the CalTrans data. We're looking at the minimum because we don't know which one of the two directions we're supposed to match up with the most, because there's no indication within the data of whether it's an AM peak or PM peak. And to kind of look at that a little bit more, what we did is here on the top left is the histogram of each of the three sets of data. So the simulation data in orange, the CalTrans hourly peak back, the CalTrans hourly peak ahead. This on the right is actually the histogram for the simulation data by itself. And so if you bin it according to 5-point increments on that scale of 0 to 1, that's the histogram for all three that we're showing on the left. And you can see that the simulation data in orange matches the back direction in the CalTrans observed data a lot better in that light blue than the purple bars in that histogram on the left. And you can see that, and then on the bottom what we did is we kind of looked at, well, in the previous slide we were just looking at the absolute difference, but if we're looking at this histogram, how does the simulation data compare in terms of what's the direction of the error, right? So this first green slice on this left pie chart means that the simulation is in the same bin on the histogram as either the CHIT the CalTrans ahead direction or the CalTrans back direction. The blue slice on that same pie chart is where the simulation we ran is somewhere between one of the ahead direction and back direction, right? So maybe our error, we might be wrong by, our minimum error might be large between the two, but maybe the two don't agree with each other very much at all in the first place, right? And then the purple shade is that where the bin is outside of either, the error is outside of the region between the two data points from CalTrans, and it's within one bin range. And then the orange is within 2 bin ranges, and the pink is everything greater. So basically, the orange and the pink are kind of our biggest errors. And you can see that's not very much of the data set. It's about like 10% of the data set, right? What we did here on the right is we did something similar where we just compared the back and ahead range. So you can kind of get a sense of, there's more disagreement between the back and ahead directions in the observed data than there are between our data and the CalTrans observed data. So here are all those points again mapped on the in these 4 regions, and so you can see that where the pink and the orange dots are pretty limited. So this is where our simulation was not within the range of either of the two directions of the CalTrans data. And this is kind of what it looks like on a statewide level, and you can see that it's regionally limited, right? And so we took out, on the left we have all the data, on the right we took out these, the areas where it actually matched really well or was within the range of the two. And so you can see it's really basically these, it's LA and kind of to a lesser degree around the Bay Area that we have the most disagreement. So I want to recap what we actually have. So the simulated traffic data does provide detailed routing information. We have a really highly detailed roadway data set that allows us to get the traffic at very specific points throughout the state. It's only providing, however, the optimized travel patterns for the state. And again, that may not be what people really drive. It is a reasonably sized sample of the full labor force. So as I mentioned, we came up with about 7.1, 7.2 million total people who were simulated by this traffic simulation. And according to the U.S. Bureau of Labor Statistics, 17.6 million Californians were employed in late 2014. We do have an estimate of what the relative commuter traffic intensity might be, and I really want to emphasize that this is just what it might be since it is a simulation. It is, however, for our purposes, a unified estimate that's similarly developed for all locations in the state and based on the same data that we utilize for our coverage calculations, right? It's using that same roadway data, that same roadway traffic speed data. Cross-checking with the limited highway observational data does seem to provide a fairly convincing argument for agreement with the simulation, and any differences appear to actually be regionally specific. They're really more highly concentrated in LA and to a lesser degree around the Bay. What it does not provide is actual observed routes for commuters. We don't know the full commuter travel pattern. We don't have every commuter in the data set. We don't know the travel patterns of non-commuter vehicles. So occupational, medium duty, heavy duty, and other vehicles are not included based on the data set that we utilized that we began with. The traffic patterns of these vehicles can affect light duty commuter traffic, and that's just something that is not addressed by the way we do our analysis. An estimate of the commuter travel via public transportation or other modes is not provided. As we mentioned earlier, the loads data set does not tell us how people got between their home and work. We're making the assumption that that's a light-duty vehicle-driven mode. It's not actually an indication of the travel routes specifically utilized by first adopters either. It's the general travel pattern for anybody in the state. We don't have exact door-to-door routes, especially in more rural areas. You get a little bit more error. And we can't really assess the validity of this simulation on lower classification roads because we don't have the observational data to do that. So here I want to take a break for any more questions.
So I have a question. So I think I know the answer, but what is it? Does it take into account, you know, trips to the grocery store or the soccer field or the theater or baseball park?
Right. So none of that is included because the data set that we have, that's the origin and destination. The destination is work and the origin is home. And so it's very limited to the commuter traffic pattern. And so we're making the assumption that if we get the commuter traffic pattern, we're getting a significant enough portion of the traffic pattern that's going to be important to people who want to be refueling their vehicle, you know, on their daily commute to work or back from work. No? Okay. If we have, we got a question. Okay.
You ready for it?
Yeah.
Okay, we just got a question online. So when will there be more hydrogen stations co-funded in Riverside and San Bernardino counties? You may be able to figure out who that is.
That I don't know, and depends on when an application is awarded. This is a data set that can be used to help determine how much of a priority Riverside and San Bernardino County are compared to other areas. But I don't have that crystal ball to tell you when the station will be funded. Okay, I think now is a good time to take a restroom break for anybody. I totally forgot to do the restroom and emergency information at the beginning. So for those of you in the room, restrooms are out the door, men's to the left, women's to the right. And if there is an emergency, we do exit out the door, down the stairs, through the lobby and out to the park across the street. So take a 15-minute, no, 5-minute? Okay, we'll take a 5-minute restroom break. What time would that be? Because that clock's wrong.
That'll be, well, we could go 8 minutes then. We'll do 2:20, we'll come back.
All right, so we'll see everybody at 2:20 again.
Okay, we'll be restarting the webinar in 1 minute. Okay, everyone, welcome back to the second part of our CHIT webinar. And we got a question over the break, so before Andrew gets started on using traffic and first adopter markets in CHIT, I'm just going to read this one question for him. It seems like the areas with the greatest disagreement between the CHIT traffic data and the CalTrans observed data are the areas where fuel cell EV markets are concentrated. Do you think this is an issue?
So one of the things that I do kind of want to make a reminder of is that the areas where there was the areas where there was a high error are fairly limited, and even in those areas there were a large number of data points that were actually correct or with very little error. So at the end of the day, I'm not sure how much that apparent correlation would make a difference, but we will actually, through this next set of slides that I'm about to present, we can kind of explore that and take a look. I mean, it's a good question. It's something I didn't think about looking at yet, or trying to highlight or dive deeply in, but maybe we can take a look at that after today's webinar and continue to make sure that's not going to be an issue. But again, the number of data points that were really out of line is 100 out of 7,000 in the state, and even in those areas where you have some of those 100, the highest concentration seems to be here across the Bay Bridge on the east side of San Francisco. There were still a good number of data points that were correct. So I'm not sure that it would be too much of an issue, but something we can definitely look at. So we'll go ahead and take a look actually at what happens when we look at trying to utilize this traffic data set with what we've already been utilizing in CHIT for trying to find the first adopter markets. So in 2015, again, here's just a reiteration of what the coverage gap equation was. We do call it heat at various times because we do a heat map analysis on it. So again, this is the same equation from before with all of our indicator values and all of their weightings. And so what we're proposing is for incorporating traffic is actually this. You can see that all of our coverage equation doesn't change. Our home-based or owner market equation doesn't change. What we're doing is we're saying that the market in total is actually partially that owner market where they live, but also partially the traffic volume, right? So the indication of where the vehicles are driving is part of what tells you where your market is. So those will, be in relative proportion to one another. And what we're going to do is take a look in these next few slides at how that might change our evaluation at various amounts of, the proportion between the home-based market and the along commute market weight. So here's what the evaluation looks like for the whole state. And on the left is essentially the evaluation we had in 2015. On the right is the same evaluation, except where we've equally weighted the home-based market and the traffic intensity that we just reviewed. Okay, so you don't have to try and strain your eyes too much because we're going to go into looking at some of those same 4 areas. But just from this, top level view, you can see how, we're still getting enough of the sort of home-based clustering of high intensity coverage gap spots. But what's happening is we're getting a little bit more variation kind of within them and around them based on the traffic data that we are trying to implement. So one point I do want to make here in this large figure on the left, this is an inset from across the bay again. And you can see that the lines on here are actually the Tiger ITN lines. This is the street data that we have. And they're colored according, I think they're colored in this according to their speed, to the actual travel speed in each section of that data set. So you can see here how fine resolution of traffic speed data we have on our traffic network. But then you can also see the analysis grid, the hexagonal grid, and those are colored according to the coverage gap that we calculate once we include traffic. And one of the things I want to point out is that even though the traffic speeds, or even though we have thin line data for the roadways, we're not only affecting the cells that literally the roadway, the major highways are on top of. We're affecting all cells around them within kind of a band as well, right? So it's not that we're making super highly limited changes to our estimations of coverage gap by including this traffic data, right? So I'll let this sit there for a few more seconds since I see Phil in the back getting a closer look. All right. So again, Bay, Sacramento in the top right, LA, OC in the bottom left, San Diego in the bottom right. And so this is what our evaluation was in 2015. Actually, this might be the revised. I think this might be the revised right before the GFO, actually. So this is maybe 2016, right before the solicitation went out. And so this is what we get if we include the traffic in a 1-to-3 ratio. So if the near home market, the core you want to put a station right close to where you live, if that's 75% of the market and the traffic is defining 25% of the market, if we when we're just going to step through different, just step through back up to 1-to-1 to see how this affects it. And so even at a 1-to-3 though, you can clearly see the difference and how those streets are starting to show up and how the traffic patterns are starting to include more highly desirable areas than were included in the first. Yeah. We'll keep doing this a couple times just so people can see. Kind of see down here in San Diego, you're definitely seeing all the highways show up, especially the 15. You can see 50 and 80. Roseville becomes actually a little bit more highly desirable already. We'll see that actually get even better when we go to 3-to-1 or 1-to-1, and you can kind of see you get more detail kind of in LAOC. So we'll go to the next one. So this is at a ratio of 2-to-1. So 1-to-1, 2-to-1. You see things kind of getting a little more intense. You won't see new lines necessarily, but you kind of see more contrast as we get more of this traffic data included. The blues are getting bluer and the yellows are getting more towards orange and red in certain areas. And then finally back to the 1-to-1, right? And you can see that Roseville, more up 80 than 50 becomes a little bit more important, and you can actually see there's, in terms of commuter traffic, there's a little bit higher intensity on 80 than 50. We can see in the Bay some of the highways leading into Berkeley and Oakland start to become really important, as well as their feeder routes. But you can also see that a lot of the highly intense areas that are along the highways and along the roads actually are feeding into the areas where we already had a high intense home area. So if we look at this bright orange-red area stretching from West LA inland, as I cycle through, you can see that really what we're getting is that we're finding the patterns that led to possibly, those that lead into those same areas, right? So I'll go back again. One more, there we go. So there are some areas where we do get high need that we didn't necessarily have before, but most of it seems to be that we're actually kind of intensifying need in areas we already had, and we're kind of extending the reach of that. Okay. So if we do decide to go ahead with this and we determine the appropriate amount of weighting between home-based market and the travel speed, or the traffic intensity market, we have this new coverage gap equation to include traffic, but that's not the end of the story for CHIT. Part of what CHIT actually does, an important part, is to take that map and analyze it, and then understand, okay, here's the spread of coverage gap across the state, but where are the really important spots? Where are the spots where the values are really high, and those values are high and concentrated locally in their area, and they're different, significantly different from the values around them, right? And so, again, if you're not familiar with that part of the operation of CHIT, I would encourage you to look at the 2015 webinar to understand all the different tools in there and how we develop that and the rationale and methodology behind that. So with the inclusion of traffic data, especially if it becomes highly weighted, we will have some issues that we haven't yet resolved, we haven't had a chance to work on with analyzing the map. But I think we have a question, so before I talk about that, let's take the question.
Sorry, we have a question online. I'm sorry, it's not online, it's on the phone. Matt, you are unmuted.
Okay. Andrew, this is Matt Forrest again. I just wanted to ask the question, looking at these two San Diego area maps, it looks like it's starting to put a little bit more emphasis on connector type stations that would be located along the freeway rather than residential type stations. Is that kind of your take on what's happening here, or am I misinterpreting kind of what's going on in these maps?
Yeah, so I think that there's definitely the possibility for doing that. What I was about to talk about on the next slide is that, yeah, we're seeing that that you do get more information about the highways and where you might want connector stations, and we may have to make some kind of delineation then between the stations that are more home-based versus the ones that are more connector-based. But it also does depend, again, on the weighting, right? Because if we go to like just a 75-25 split, you can see here like the 15 in San Diego, it's a yellow, there is some orange, but still your highest concentration of deep orange is still, kind of Mission Valley and downtown area, right? And so that would probably be identified as the higher, more of the clustering of the high need areas. So I think at the end of the day, we still want to be able to get something that's a cluster kind of effect, and be able to make a recommendation that is similar to what we did before, where it's got enough of the home-based networking, but within that we might have, more the differences between particular areas might be more informed by the addition of the traffic. And then we could also look at separately making recommendations based on connector type stations. But none of this is written in stone. That's part of what we're hoping to kind of get feedback on today. So if that's something, if that sounds like something that's of interest, or if that's not the way that this seems to that this would be useful, then that's definitely input we would like to take.
Okay, thank you very much.
Yeah. So a little bit, on that topic actually. So on the very left panel here, and on the third from the left panel here, are the priority areas as they were identified in 2015, and you can see that they're nice polygon shapes. They've got, they're broad areas, whereas in the second panel and the fourth panel, this is in the same areas, but you have the evaluation of trying to identify the hotspots using the same tool we developed in 2015, but now that you've included traffic in an equal portion to that home-based market. And so there are problems here that we have to be able to resolve. So first of all, you have narrow and small regions are more difficult to recommend, and you can see you get some of these, like up north of San Francisco on the 101, you have this one long, narrow stretch that would be identified as a priority area by our tool so far. And that's difficult to recommend because that provides less flexibility to applicants, right? There's not a lot of land areas to try to find a station there, right? It's long and narrow. We also do have the effect where disconnected home-based hotspots end up becoming joined by these high travel routes. So let's look at the LAOC one pair, LAOC San Diego pair on the right, right? So the second from the right figure, you can see there's 1, 2, 3, 4, 5, 6, 7, 8 different, 9 different priority areas, and they're all disconnected. If we start to include traffic, all 9 of those actually get connected together into one giant priority area recommendation, and that's not entirely informative on its own. So we do need to find some way to strike the balance between, if we do include the traffic information, between still wanting to have these kind of pockets, right, for priority areas versus, they just happen to be connected because of the high traffic areas. So one possibility is we are probably going to have to revise our map analysis tools. I have not had the chance to do that yet, so I'm just presenting this today as an issue that we will have to address going forward if we utilize this. But what we can do is we can do separate analyses. Essentially, we could do one analysis without the traffic to try to identify our home-based only kind of markets, core markets, and then one with the traffic to try to see, okay, well, maybe those can be expanded, at least without the portion that's just these, long branches that are connecting these, connecting the individual pockets of high need, and then also maybe look further to how could we possibly use those branches of those connecting highway routes to be recommendations for connector stations. So this is kind of an open issue, but we do want to just make everybody aware that we will probably have to develop new tools to analyze the coverage gap map. And then to possibly look a little bit more at the possibility for connector stations, one other way we were thinking about possibly doing this is utilizing the coverage mechanism that we use, the algorithm that we utilize for the home-based stations, but kind of modifying it. So again, our coverage accounts for multiple overlapping service areas, and basically the way it works is in this example on the left, this bottom left, say, analysis cell has service provided by 2 stations, one station within 6 minutes, one within 5, whereas the top right only has service provided by 1 station 6 minutes, 6 minutes away. 1 minute away versus 1 and 3 minutes, not 6 and 5. And so if a station's within 1 minute away, it has more coverage. It has a higher degree of convenience to that cell. But if you have 2 stations that are reasonably close, that cell has even more convenience, more coverage provided to it. And so this is kind of the basis of our coverage calculation algorithm. And for the core market analysis that we did in 2015 and have been doing, we look at 1, 3, 6, 9, 12, and 15 minutes. And so just our first kind of proposal for seeing how we could adjust this for connector type stations, we could do the same kind of analysis, but where we change the cutoff points to 30, 60, 90, and 120 minutes, right? Based on maybe if you're assuming connector stations are for long distance travel, looking at 2-hour travel before you want to refuel. It could, of course, be longer, but we're trying to err on the side of more conservative estimate here. So if this is our statewide overview, this is just the traffic now. This is not the heat map. This is just the traffic. This is the coverage that's provided by the currently funded stations if we utilize that reassessment of looking at 30, 60, 90, and 120 minutes, right? And so if we overlay the traffic with that, this is what we get in terms of where are the areas that you have high traffic that are not being served by the stations in terms of being a connector station, right? So we'll look at a whole bunch of different areas and then kind of summarize what we find. So here's the Bay Area. Here's the Bay Area. This is the Bay Area traffic. This is the Bay Area connector station coverage. And then, oops, there we go. And so this is what you get as a result of that. I'm kind of ignoring everything between Sacramento and Modesto for this discussion right now because it's on another slide. But within the Bay Area, you can see that actually, other than going across the Bay itself again, really the 101 is kind of the highest, has the least amount of service for the amount of traffic that we simulated, the least amount of service and coverage from a connector station that compared to the amount of traffic that we simulated. And we'll continue to go through different areas. So this is LAOC. There are a number of stations in LAOC. So if we overlay the coverage, then everything's pretty well covered. You can still see like kind of I-10 and some other areas, but at least from what we simulated so far, it seems to be that there aren't too many stretches that would need another connector type station. That's not to say it doesn't need another local station, right? There's no evaluation of the early adopter market here. This is only traffic. Coastal Orange County, pretty much the same thing, though maybe out on the 91 somewhere and the 55. San Diego, there's only 3 stations and it's a high traffic area, so a lot could still be done there in terms of connector stations if we're utilizing this as our marker for connector need. Sacramento, same thing. So basically the I-80, I-80 and the 50, and then the 99. Parts of the 5 maybe leading into further south of the city, south of Sacramento, could use another connector type station based on this analysis. And then if we look towards the north of the state, we actually see that maybe the north of the state doesn't have a lot of need yet for early adopter market core stations, but maybe in terms of connector stations in particular, out by Eureka, between Redding and Chico, between Chico and Yuba City, and then on 49 between Sacramento and Grass Valley. Those all seem to be concentrations of high need for a connector type. And then, in the desert cities, we can kind of see, along I-10, 111, 62, 86, and actually not on this slide, but part of 15 also could utilize it. And then in the Central Valley and the Central Coast, along 101 north of 198, between San Luis Obispo and Santa Maria, and then here's where we can kind of see all that detail between Bakersfield and Fresno on the 99, and then even some of the kind of east-west connectors out of some of these cities on the 99, like the 178. So this is just our first kind of cut at looking at this possible use of this data. And so here's a summary. In the Bay Area, current core market stations cover the traffic patterns pretty well, but an opportunity may exist along 101 north of the peninsula. In LA and OC, long-distance connector travel seems pretty well covered. San Diego, opportunities exist along a lot of places, I-15 and I-5 leading into San Diego from the north, along 805, I-8, and these various state routes between downtown and El Cajon. Major highways near Sacramento, including the east-west routes of I-80 and 50, and the north-south I-5 and 99. Again, a lot of this isn't really surprising because a lot of these are major highways, but at the same time, it's good to see what the comparison is to what we've funded. In the northern areas of the state, I-5 and 99, especially between Yuba City and Redding, 49 between Sacramento and Grass Valley, and US 101 and 299 around Eureka. And then between the desert cities of Palm Springs, around Palm Springs, especially along I-10 on the eastern end, 111, 86, 62, and 15. And then in the Central Valley, north-south connectors along the 99 are the greatest need, although some of the east-west extending from 99 appear viable as well. And on the coast, 101 and 227 and others, especially near Santa Maria and San Luis Obispo, and 101 north of the intersection with 198. So those were all those areas that I had kind of highlighted on the previous slides, but this is just kind of the rundown of them. So those are kind of the ideas that we've had so far. I don't know if anybody would like us to go back to any of these particular slides to review the images for a little bit, but those are the ideas we've had so far for how we might incorporate the traffic data, both for looking at how to suggest core market areas for new stations that serve core, early adopter markets, but then also how we might utilize the traffic data by itself along with the information of the funded stations to try to determine where connector stations need to go. And it's kind of the first time we've tried to do this with our GIS analysis tools. So definitely looking for input. Yeah, so
Phil Kazel from the Energy Commission. So did you take any time to consider maybe another term for the intermediate stations rather than connector, which would be long distance or local? Is there a definition you could call a commuter station or something else that would be a shorter distance filler between markets?
So, and are you asking are you saying just in terms of what we call these stations that I've identified here, or also looking at a different analysis where we're using kind of different cutoff times than what I use?
Well, I don't know. I mean, you could use whatever cutoff time makes sense, but it seems like some of what we call a connector today could be, a long distance between markets. On some of the maps that you're showing, it's a shorter distance, but we're still referring to them as kind of a connector based on traffic.
Right.
Would there be a need or a better way to characterize those stations that would be on the highway, but not necessarily a long distance connector?
Yeah, I think there'd definitely be some value in making sure we're clear about what the purpose of a station in any particular recommended area would be. And I would probably open that up to stakeholders to make sure we get consensus on what those definitions are, to make sure that we're all understanding what. But yeah, I think you're absolutely right. Looking at this list of highways and the portions of them that were shown in each of the different maps of the different areas, are definitely different distances and different kinds of commutes that are different kinds of travel that you would be building for. Yeah, I totally agree.
This is Jane Berner with the Energy Commission. So I just missed it. In doing this connector analysis, did you use the commuter data set that you, okay, so not just general AEDT, you're using the
No, this is
data.
Yeah, from the same simulation data. Sure. Yeah. Yeah, we don't have AEDT data that's, oh my gosh, too many animations. Yeah, that has this much information on it, right? Yeah.
Ms. Jenks, Energy Commission. I basically just have a comment. I was kind of just wondering if maybe the people who are driving fuel cell vehicles might have different commute habits than the general public in terms of if they're more affluent, they'd be able to afford to live closer to work, and also if they're more environmentally conscious than the average person, then they might also tend to want to shorten their commute for that reason. Maybe that could, maybe when more information comes in for rural hydrogen stations, we could use that to determine whether that might be the case.
Absolutely. Yeah, that's one of the things we mentioned earlier. We're not simulating exactly the early adopter market. Having said that, we think we can't get to that with the data we have, but we think we might be able to get to something close. That's actually the next section too, so maybe we can, but we haven't done it yet. It's another, basically the way this presentation is kind of like from the thing that we've done the most part of towards the things that we're still trying to figure out and get some stakeholder feedback to understand if it's even of interest to stakeholders to try and keep going further and further with this traffic data set and what exactly we can do. So we'll talk about that in a minute, but you're absolutely right. We're not in particular getting the commute traffic patterns for any particular demographic of the state. It's just approximately half of the working commuters, right? Yeah.
Lance Atkins with Nissan. I was wondering, why can't you get the early adopter data out of your total data set, given that you've already identified the geographic area? And maybe you're going to touch on this.
Yeah, basically. So let me just go to the slide directly instead of having a. So that's kind of our concept. Is we don't even in our early adopter metric identify like, okay, this household has 3 of the early adopters and this one has 0. We just identify the relative intensity of the indicator factors that we're looking at within each area, right? So, but what we can possibly do is, since the consideration of travel routes is generic, it's not in any way explicitly known to be the first adopters, right? But we do, like you said, we have all the origins and all the destinations, and we know which side is the home, and so we could kind of add an additional weighting factor to every travel route that's based on what the early adopter market calculation is, right? And then say, okay, again, that still does not necessarily mean that the first adopters are directly simulated, since we don't know that all the destinations are actually the destinations of the first adopters commute, or even that they're doing that commute, as Chris brought up, right? We don't, we're kind of making assumptions that everybody's kind of the same in their commute patterns and all of that, but it may not be correct. They may not be driving at the time that we're utilizing our on-road traffic speed, right? So those are all unknowns, but we can try to, if it's considered as a probability weighting factor, right, essentially, right, that we could implement that. We haven't started that yet, but the data are available. The calculation probably would take time, and we probably, I'm guessing, would not be able to have that. If we did that, I'm guessing we wouldn't have time to get that done for the June report, but that doesn't mean we can't or shouldn't do it in general. So if that is actually something that seems to be important, understanding all of the caveats we put here, right, that we're still not really actually getting the first adopters, or even what, and also other than what we think are the first adopters versus what are actually the first adopters, right? With that understanding, is it worth pursuing and trying to incorporate? So yeah, absolutely, it's something we can do technically, or there's no technical barrier to it. It's just we haven't had the time yet. No questions online? Okay. Any other questions in the room?
I'm sorry, we just had a question pop up. Again, it's Matt Forrest. Matt Forrest, you are unmuted.
Okay, thank you. Andrew, just looking at the the development of the maps, it looks like the tool is getting more and more specific about where stations should go, and I guess in a way to add additional value. And I'm wondering, do you perceive a trade-off in becoming more and more specific about where stations should go, and perhaps at the detriment of allowing station providers to do their own market analysis and suggest where stations should go? I mean, if you were to visualize a cone or a funnel, it seems like the CHIT tool is getting closer down to the narrow end of the funnel, where you potentially could move it back to be less prescriptive and try to just get stations into a more broader area. Is the goal of the model development at the moment to get more and more specific, or is it more to kind of enable the market to transition from kind of the fledgling market that we had years ago to the market that we want to have in 2023? I'm not sure if that question comes across right, but I can clarify.
Yeah, no, yeah, I think absolutely. The inclusion of the traffic data, because just the geometry of the roads are, more narrow and more precise, does make, the gradations, more in recommendations and in certain, intensities of coverage gap definitely, more limited, right? You can see in, well, let me not use this figure, but here, right? Going back to San Diego, you can definitely see that, along I-15, along 15, right? The recommendations for where stations should go is definitely a more narrow area than this kind of, the area actually down in downtown that you had before utilizing any of the traffic information, basically, comparing the left to the right figure. Mm-hmm. So you're absolutely right there, and we are not, again, the intent of CHIT is not to be the prescriptive tool that tells you this is 100, corners where you need to put a station. So you're right, again, just by the nature of the type of data we're putting in here, we are kind of taking a step back away from being less prescriptive and towards more prescriptive in that sense. The one thing I would kind of add as a reminder is that CHIT is not the only thing that is utilized to determine station locations, and even in this last round, the location and capacity and market viability scoring criterion was not only informed by the CHIT determinations and the CHIT values. There was the opportunity for applicants to provide their own narrative and their own analysis of, whoops, I don't know what happened there, their own analysis of what the market viability is for the stations that they wanted to propose. So I just want to kind of make that reminder that at the end of the day, yes, we don't want, or you're correct, we don't want CHIT to be trying to tell people, not give them flexibility, and trying to limit people to, it's got to be this corner and whether or not there's a gas station there, right? Because that's also something that's not even in here, right? But at the same time, if we do get more specific data in terms of how geographically refined it is, that's not the only thing that goes into the determinations. So yeah, I hope did that answer your question?
It does. Thank you very much.
Yeah.
Was there anything more to your presentation?
Oh, yeah.
Do we have any questions?
Go forward.
Okay.
All right. So, oh, man, too many. I think I'm almost there. Okay, we talked about this. Okay, and then this is my last thing. So the wild card. So Chris earlier brought up Google data or Waze data. I honestly haven't looked too deep into that, but from what I knew before, like kind of the only way to get at that data is to be a developer and have agreements and all that kind of stuff. But on January 8th, 2017, Uber announced Movement, and Movement is a platform that allows planners to leverage data collected by Uber's drivers. So I guess this whole time they've been collecting information about where their drivers go. So the platform's not yet released. Details have not been given of what's actually going to be available. But what I will highlight is that one of the specific things they mentioned in their announcement is zone-to-zone travel time. So the issue here is that ARB is signed up. It sounds like it could be free to public agencies, but they haven't announced anything about cost yet, so I don't know that for a fact. But one of the things I'll highlight here is that, you know, the piece of data that they mentioned was basically traffic speed information. And so that, other than refining our ITN Tiger data set that underlies our own simulation, if that's what's coming out of this data set, then that won't really help us make a direct, you know, change to, or a more direct estimate of what the volume is, right? I was trying to imagine in what way, what sensing technology they could have on their vehicles. As far as I understand, you don't get a sensing technology, you know, sensor box from Uber when you sign up, so I'm not really sure what they would be able to provide in terms of traffic volume, but we're definitely signed up to find out what they might have and what might be available. So, you know, I can't say a lot about this because it's all still not public information yet, but we're watching this, and, you know, maybe this is in the future another piece of information that we can utilize. You know, even if we can't utilize it directly, maybe it's something we can utilize to validate some of our own other information. So, yeah, at this point, this is where I left time for kind of open discussion, and what I want to kind of, you know, really get out of this is that, you know, what potential uses for the simulated traffic data should actually be utilized in particular for CHIT 2017 and beyond, right? And in particular for this next June report. So questions are, should the CHIT traffic data be implemented at all? If it is, you know, do we think it needs to be given a pretty high weight compared to the, you know, early adopter home market data that we have been using all along, or should it kind of just be just given a little bit? Should we even be trying to utilize it for connector station information, right? You know, we put out there just a, you know, prospective use of it, but we want to get some feedback on whether or not that actually is effective. And then also, do we actually need to try to implement that factor that Lance was asking about, or had mentioned, that, you know, since we know the home base, you know, the starting point of every one of these commute patterns, or these commute lines, should we weight every single commute by the chance, or by the actual early adopter market value that's assigned to that census block, right, or overlays that census block? So I think those are 4 questions. I probably should have actually put those on the slide in particular, but so yeah, this is open discussion. We really want to get some stakeholder feedback. So and I can of course answer any questions that are remaining too. So.
Well, we do have a remaining question that, before, from someone online. They want to know, does the CHIT project plan to incorporate and quantify the need for stations at or en route to popular destinations like Lake Tahoe, Yosemite? How important are these markets compared to near home and along travel markets?
Yeah, so like we kind of touched on this earlier, that the traffic data we looked at, the base data set is only the commute, the home to work commute. So, you know, we can add more information. I mean, we began this process of trying to include the traffic information based on stakeholder feedback and stakeholder requests. So CHIT is a public tool, and if it's deemed to be that it needs to have more information in it, we can go ahead and add those features, add those data layers, but we do have to also make sure that we actually have the data. I admittedly have not looked very much into it, but I am skeptical at first about how much information there actually is out there available about how many people from any given neighborhood go to any one of them, you know, hundreds of different destinations in the state. Maybe it's something that we can back calculate or infer from some other data, but I think finding that information would be difficult, and unless there's been some study already done on it that's kind of figured out some of that. But So I guess the shorter answer is we could do it. It might take a while, but we could do it if it's really necessary.
Does anybody have ideas and discussions for Andrew in terms of he came to do this so that he could get information from us?
This is Chris Jenks again, Energy Commission. I was just trying to think of how that, you know, using the traffic data would serve people in terms of the stations. And I was imagining, suppose that we knew that an early adopter market were right here in downtown Sac, and suppose that we also know that the people commuting in here tend to go to, say, equally to Davis, to Woodland, to Rancho, and also work right here. Mm-hmm. So what that means, I would think, is that if you put, say, a station in Davis based on that, you would only serve a quarter of the early adopters here because the other 3/4 would commute somewhere else. Whereas if you put the station here, then you'd serve all of them because they all have to come home here and then they could go to that station. So maybe if we knew where early adopters tend to work, then that would be another thing to put into CHIT rather than where the people tend to commute in general.
Right. Yeah. And like I said, I don't think we can get that particular data point because we're trying to estimate who the early adopters are. So then trying to estimate pick those people out of the data set to figure out, but where their work locations are. But this idea of that we could weight those traffic, we could weight every single route that we calculated by the home early adopter metric value, right? Then that kind of gives a weighting towards, you know, how important that traffic route is, right? We need a survey. Well, yeah, well, we need a traffic survey. That's going to take a while.
Lance Atkins with Nissan. I kind of think you do want to look at that early adopter metric. One of the principles for CHIT is it models the early adopters. And the issue with the commute data, the way it's being used now, is it's all commute data for everybody. So your values can get skewed just because you have a large population that may or may not be an early adopter who happens to travel a lot on that road. And so not waiting at least somewhat for that early adopter group, or at least the travel that originates from an early adopter region, seems like that's maybe a potentially bigger error than some of your other ones that you're concerned with, which are actually maybe not that significant in the big scheme of things.
Right. Okay.
Thanks. Jean Baroness with the Energy Commission. So the price of gasoline impacts how much people drive. And I think that there's studies that show $4 a gallon is really eking into this area where people think twice about driving their car to Costco or to the field trip for school or to a picnic. So commuting data, I'm hoping, is connected to the price of fuel, traditional fuel. I think if you look at a data set that shows commuting in 2008, you would see very different traffic heaviness in certain areas of our state versus today when the stock market is over 21,000 points, for example. So there's this price sensitivity with commuting, you know, and I know it might be related to what someone does for a living, or if they're a college student, or if they're a high school student, but we speak with our wallets, and whether or not you're going to pick up the keys to a gas car or in any car may be impacted by how much money you have in your wallet, or what your income is that year, or what your family needs are that year vis-a-vis their income. So I see it as very connected to commuting. The price of conventional fuel, the stock market, and the economy. So I can't see how you can work with commuting data without taking into consideration all the impacts of just the economy.
Right. Well, and given the financial metrics and the heavy weighting towards financial metrics in our early adopter market estimation, we aren't explicitly including stock market or gasoline price information, but those metrics where essentially higher income means you're more likely to be that early adopter, that could be kind of surrogate for some of the information that you're talking about. So it almost sounds like, to me it sounds like you're kind of also in support of this idea that we should be weighting the each individual commute route based on how likely it is that the home portion of that, or the home point from that commute route, is actually an early adopter market.
Mm-hmm.
Yeah.
Because the veins have to connect to the hands and the feet. So it's not just us commuting on these freeways and then other roads, but it's also plus where we live.
Right.
So
yeah.
Because, I mean, I'll give you an example. In the community college system, I know teachers make a concerted effort to know whether or not their students can go on a field trip based on whether or not their students can afford, or want to pay, part with their money. If the gas price that day or a year is $2.50 a gallon, or if it's $4.50 a gallon.
Yeah.
It affects how much road we use and how much we drive.
Right. Yeah. Yeah. So those like, I guess, annually varying or even seasonally varying dynamics of traffic, essentially VMT, right, are not included in this. They're not accounted for in this. This is just a straight up simulation of if we know what everybody's home and work is, and if they're driving there, then this is what we think the pattern would be, right? And I don't know, I don't know how we would incorporate, but absolutely valid. Like, it would change year to year. At the same time, so far we tend to use somewhat static data, right, in our CHIT evaluations. We do update, so for example, for this 2017 release, we will update all of our census data, demographic data from, I think back then it was a 2013 census, so this will be the 2015 census, right? So we still, everything we do is still like a snapshot moment in time, right? And so I'm not sure yet how we could implement something that's more dynamic like that, but we can try and figure out, see if we can figure something out.
Well, actually, we're getting a comment from someone on the phone on the topic. Matt, go ahead.
Yeah, Andrew, I just wanted to follow up on what Jean just said, and that is that in general, if you look at times where the condition of the economy is worse, it tends to price certain people off the road. And I would say that in general, the people that are going to be early adopters, early purchasers, early leasees of these fuel cell vehicles are people that are able to afford vehicles at those price points, and therefore would be likely less impacted by a slight, $1 change in fuel price. It may be that by targeting particular years, you might be able to kind of quiet the noise of everybody commuting down to the people that are most likely to be targeting the vehicles that you're looking to study.
Oh, I see what you're saying. We could, for example, use a 2008 or 2010 vintage of commute patterns. So possibly. The thing that would be difficult is that, again, the only data we have, really what we're doing is we're taking a home and a work location and assuming people are driving there. So when the economy is down, somebody who can't afford to drive may be taking a different mode of transportation that's cheaper, and we don't know that from our information. And also when the economy is down, they may choose to still make their commute drive but sacrifice the vacation or the destination travel drive. And again, that's something that's out of the bounds of this. That's part of one of those limitations that I put up there, that the data set we have, it is admittedly a limited scope of the full traffic pattern across the state, and these are all definitely very valid concerns. And so it's that's part of what I want to get at are these concerns big enough that that causes a fundamental problem with using this data set, or do we think that there's still a way we can use it, or do we even want to use it? And but I think this is a good discussion point to get there.
Yeah, I think if you're strategic with how you use it, then you can definitely give yourself a position of strength. If you just use something because it's convenient, then it might be harder to justify. So I think that there's a number of approaches, and it's just a matter of kind of stating the initial conditions of the model. But I think that, you know, if you're looking to kind of get more, I think, to Gene and to Lance's points, what early adopter vehicle user might look like, I think that kind of you might be a little bit more selective in the data to kind of give you a closer look. So just wanted to make that point. Thank you. Thank you.
Okay. Thank you.
So Andrew, this is Lance, one of the things that I'm thinking about with the data, I like the idea of being able to use the commuter, putting it into the commuter group. You will get a finer view, perhaps, of how that traffic flows and where it flows to, which is helpful for stations. But Matt made the point earlier, and I'm struggling with, is that so good that you should then score based on that finer resolution? And that part I'm not sure at. But I think understanding is valuable. What we do with scoring maybe is a little bit different, but maybe we retain the understanding value within the model.
Okay. So it kind of could be more of just the traffic data could be more helpful towards validating the recommendations of the particular core market areas, kind of, right? Okay.
Chris Jenks, Energy Commission. I was just wondering, might it be possible for the car manufacturers to provide you with the addresses where the people buying and leasing fuel cell vehicles work?
That's not for me to answer, but so we'll remind, well, so we do get registration data. Registration data will give us their home location at least. So we are knowing where, we do know, well, as far as an actual registration address is actually the home address, right? Because some people maybe have their registration address as a P.O. box, right? As far as that accuracy, we do know where the home-based market is developing. I don't think we can get that information from the, I may be able to look into whether or not we can get that information from the rebate program, the survey. I'm not sure that we can due to data confidentiality requirements, but I can look into that and we can see. Again, the one issue with, or probably the biggest issue with that is the limited amount of data, right? We're still in the very beginnings of the market developing. So what we see now is like, oh, this area is the highest area. It might just happen to be right now, for now, the highest area, right? I mean, I'm sure all the OEMs are strategically placing based on what they think is the most important as we go on throughout time, and we'll see that develop, but right now we don't have the full picture, I would think, right?
This is Jean from the Energy Commission. So I'm just suggesting, I know, Matt, you were talking about how the socioeconomic strata might delineate between the sensitivity toward the price of gas today or fuel of any type. So can that be filtered out is what I'm wondering, you know, so that it's not really going to influence, and it'll still give you an overall heaviness of traffic or lightness of traffic and direction of traffic.
I mean, one thing we can, maybe one thing that we can do, sorry, I'm tripping over my words here, is we could look at, we know the vintage of the data that we have, 2014, and we could kind of look at some measure of the price of gas at that point, and then we could utilize that versus what is our current price of gas as sort of to help inform what the weighting between the traffic data and the home-based market data should be. Maybe that could be part of it. That's just.
And then the other thing is, I know in the Bay Area, people are expecting this huge growth in terms of people coming to the Bay Area to live. It's, you know, they're talking about 20 million people by 2030 will be living there. And the Bay Area is going to become much longer, so to speak, going all the way down past Cowley Point and down by Gilroy. It's going to be considered the Bay Area in the future. So you have all this, you have more traffic.
Right.
So you have more need for the stations and you have more need for vehicles in general. So I think it is important to put a vintage on the traffic of the year of the data for sure, because it's just becoming. I can see it in the Bay Area. It just seems like more traffic.
Right.
When I live there, so it's more traffic, So that's one thing. But to Lance's point about scoring it, so would it work that we could get, in the Energy Commission GFO 15605, we have this market viability criteria where the score team looks at how the applicant justifies their application and gives details on the throughput and the commuter traffic, actually, and the traffic generally. And so would this be able to provide the score team a way to actually have a quantitative score for that in the future, as opposed to this year, I think the team, and tell me if you had it, was a qualitative, kind of a qualitative evaluation of that market viability. But I think this would allow a number to be placed on the market viability because of the arteries you showed and the throughput you showed. Right. Isn't that how it would work? I'm looking at the score team members too to talk about that.
Do you guys want to speak first, or I can, or Phil? Yeah.
So this is Phil Caseville from Energy Commission. So in the last round of scoring, you provided us with capacity and coverage. And then in these maps, you were showing the overlay with the traffic. Could the traffic be split off into, a different value that could then be weighted based on, other factors to make it to make it less than just affecting the whole CHIT score? Could it be another addition to it?
It could be a third map, essentially, because the capacity and the coverage gap are essentially two different maps already. So then we could have a third map that is traffic. So from my recollection, based on my recollection of the applications is similar to what you were saying. I think there was somebody, or at least one or two, who were using annual average daily traffic. But again, that was coarse data, and they'd say, oh, we're near a high AADT highway, right? But you didn't necessarily have the local, what that meant on the local level. So I would say that, yes, this is an idea that could literally today be implemented. The only caveat is we have to, we should only use it if we do believe the data, right? And insofar as we've validated it so far, right? So if we think the data are correct, or if we think the data are correct, at least once we add in the weighting for the early adopter metric at home, because I think that's the only way we can really get to that, limiting that ability to limit which of the commutes we're actually counting or how heavy we're counting every commute, then yeah, that's something that we could implement immediately. So we'd basically have for future scoring, we'd have 3 different maps.
So this is Jean Varenis from the Energy Commission. So Andrew, one of your slides, I think you were showing San Diego, and you said, well, this is kind of a long, thin polygon, or long, I think you said long, thin.
Long and narrow, yeah.
Yeah, yeah. And I think it was San Diego.
Well, the one, I think when I made that particular comment, I was pointing to the Bay, the 101 north of San Francisco. We kind of had here. So, whoops. So right here, basically, and this was, I mean, admittedly, this is a result of running our kind of map analysis tools without any changes to try to accommodate for what we kind of figured would happen. This was just if we use the same map analysis tools from 2015 that tried to identify hotspots, right, we would possibly get, it's kind of hard to see maybe, but there's this pink outlined line right here, and that was identified as a hotspot, and that's just the 101, right? So, and it's, you can see it's long, narrow kind of area. It's hard to recommend that because you're not giving a lot of leeway in terms of the areas of possible, sites for a station, right? There might be 3 stations along that.
But that could be brought into this. So I think you were speaking earlier about our data analysis division's gas station database.
Mm-hmm.
So why not have that long, thin, worm-like thing be a potential worm-like thing, and it gets a CHIT score for traffic throughput with some qualification of the richness or lack of gas stations along the route, assuming that gas stations are really the place to be putting these dispensers. I mean, that's
Right.
another assumption, right? That
Right.
may or may not be important to people. And we've seen in the past where people identified non-gas stations as possible opportunities for a dispenser or two. That's to be considered too. There's nothing to say that can't be. But the worm-like thing, when you were talking earlier during your presentation, it didn't bother me at all that would be considered a possible scoring blob or worm. So, because it's got orange.
Right.
It's got high car traffic. And it could be the worm-like thing even takes care of the issue of the sensitivity with a $4 gallon of gas or a $2.50 gallon of gas. So, because it's so desirable to have dispenser along there, why not use it as the third CHIT dimension? So CHIT no longer is 2D, it becomes a 3D.
Yeah.
Is what I'm getting at.
Yeah,
like,
I mean, I would probably want to, I probably want to look at, kind of running a prospective analysis for that to see what the, what we actually get out of it. It may be something valuable, you kind of, if we're correlating the traffic hotspots, right, with the locations of gas stations, maybe it's some, number of gas stations and average distance that, can become some kind of metric in addition to the traffic itself, then maybe we could come up with some overall metric for how good of, maybe that's a connector, maybe that's what we call a connector type station, right? So I could look into that and kind of develop a map to try and figure that out.
So you're calling them corridors, and what occurred to me are the maps that Jennifer Allen of the Energy Commission uses for her EV corridor, the California Corridor project she's on, where she'll put EVSE along the corridors.
Right.
And it's almost like bringing fuel cell into the corridor concept with this extra data layer, if you want to call it that.
Yeah.
And in the case of EVSE, she's using corridors as her way to guide her and her team to place EVSE.
Right. Yeah.
Now, I'm wondering out loud here if the San Francisco tip where San Francisco proper is becomes less orange if you had a worm corridor above it that's orange.
So one thing is that this is the map for if we wanted to assess early adopter market and traffic together as kind of our market definition, right? I think maybe for what you're talking about, the more appropriate map is really this map, right, where this is just the traffic itself. And you can still see that this is the traffic when we're accounting for, what is the connector type coverage provided by the current stations, right? And when we do that in the Bay Area, that same kind of stretch of US 101 is kind of what stands out still, right? But you can see that, yeah, definitely San Francisco itself isn't standing out so much when you're not accounting for the early adopter, when you're not including the early adopter metric as part of your assumption of what the market is, right? And we'll see. I mean, that traffic going up 101, more than likely a good portion of that is coming from people in San Francisco, right? And so that area is a high early adopter metric area, so it is entirely possible that that same stretch would be really highly scoring once we weight the traffic routes. So
yeah, so I'm thinking out loud. This is Jean from the Energy Commission. I'm just wondering how we went so far without this. That's where I'm going with it. I'm like thinking out loud here again. I'm going like, now, okay, so you have this San Francisco early adopter market that drive.
Right.
And so they go from home to driving on the freeway. So it's just so logical to me. I'm sitting here going, this is so logical to want to use the driving data. And,
right.
And someone said to me about a month ago, no, you want your stations near your home. I said, no, actually. In Atherton, California, people don't want a gas station. There isn't one. Those homes, which are the early adopter market homes, that has the most Tesla in the nation, no gas station. Those homeowners do not want a gas station near their home.
Right.
Or a fueling station near their home. They want them away from their home. They don't want a Costco, they don't want a CVS, they don't want anything there. They just want those homes and those pools. And they would want the Worm 101 project funded.
Right. Okay. I mean, yeah, I think these are some good ideas we can start to work on.
So this is Phil from Energy Commission. So I know with the classic CHIT outline and core market areas, we're trying to look at, putting a station in a hot area. And then when you add the traffic, we're trying to decide, is that roadway the hot area? So maybe it's not that, right at the road happens to be a new core market, but it does indicate where the traffic flows.
Right.
But then that being said, I don't know, does it inform us to know that 101 is a heavily commute area, along with all the freeways in LA? You could look out the window and confirm that, oh yeah, there's a lot of traffic on that road, unless it tells us where people are getting on and off, coming from, nearby core market areas that could be a hub where they would refuel.
Right. Well, the one thing this does allow is, assuming the data are correct, it does allow you to have a quantified value to say, right, about every point, right, essentially, right, that, yeah, we all obviously know 405, is high traffic, right, but now we have, we have a metric that was evaluated across the state consistently to be able to say, yeah, 405, here you go, here's a number for it, not just, okay, we think 405 should be high, So, I mean, that's one benefit, but yeah, absolutely. I think we need to carefully decide how we want to use this, right? And that's with these last two kind of statements, that's kind of what brought us to this point, right? Is this whole question of, well, you can easily see you want your station near the home. You can also easily see you want your station on a driven path, a highly driven path, especially and preferably the highly driven path of those people who are going to adopt the vehicles, right? But those are going to probably give you two very different types of recommendations for where the stations need to go. So what is our kind of, should we, find the happy medium? Should we really just continue to lean towards the early adopter metric? Should we try and incorporate more of the traffic? Should we use them separately? Should we use them together? Those are all those questions. I think I've gotten a few answers today, so that are going to be interesting to look at over the next few months.
So may I ask another one? So this is Jean Baroness with the Energy Commission. So big part of our scoring this time around was the location, coverage, and then the capacity. So just a leading question here, how would you rate the Worm's capacity need? The Worm has maybe a less capacity need than San Francisco.
So
as a blob, right? It's a collection of people living
right.
in San Francisco.
So I'd go back to, so the way we can, actually I don't think I presented this because we developed this after the 2015 webinar. So and in the webinar later this year, we'll actually probably have the derivation of it. But the way we did the capacity estimation is basically we take every block group in the state. So we take that center point of that block group and we calculate its 15-minute radius, right? And we use that to kind of determine, okay, you know, how many vehicles are within this 15-minute radius that are probably fuel cell vehicles based on distributing the 43,000 that we had, right? And then what we do is we say, okay, then within that 15-minute radius, we know how many vehicles should be there in this one block group, and then how many stations are within that 15-minute radius. So we know how much fuel should be consumed by that group, how much fuel is available to that group, and then we do that at every single block group across the state, right? And so you get the slight variations as you go from one block group from, you know, over here to another block group a mile away, and then we have that data point at every single one of those, and then we interpolate in between. And that was the origin of the capacity estimation, the capacity need estimation. So that method doesn't really, essentially doesn't care about, you know, what is the topology of the streets, right? We're looking at literally every block group. We're assessing the local need, right? So I think it wouldn't matter. I think you'd still be, you wouldn't need to incorporate this traffic volume data into that assessment because you're already got kind of like, where are all these people, you know, likely to be? Yeah.
So some of the fuel cell drivers I talk to say I'm driving more than I ever did before. I feel free. I feel like I'm not worried about the environment and what my vehicle does to the environment anymore. So now if someone says, let's go out and shop for discounted shoes because they're on sale today, I don't worry about it anymore. I'm driving my fuel cell car. I'm happy to drive now. Mm-hmm. So there's a whole nother phenomena. I'm sure people are studying this about how free. I mean, we have a person in our office who has a Prius, and I asked her, do you feel free to drive? Do you have this feeling like this? She goes, yeah, I feel like I can really drive. I'm sorry to use the brand name. I know Kellyanne Conway just got in trouble for that. But what I'm talking about is the concept of ZEV makes people freer to drive, and they're driving more miles now because they're not so scared about the environment.
Yeah,
their impact on the environment.
Yeah, we're actually funding a study with UC Davis that's looking at essentially that. So there are households through this study that are signed up that have gasoline vehicle, you know, some combination of gasoline vehicle and green vehicle, including fuel cell vehicles, right? There's some BEVs, there's fuel cells, there's plug-in hybrids. And what the study is looking at is kind of what are the decisions that people are making in these households. So you've got different households that have different, essentially available car makeups, right? And if anybody from UC Davis is who's involved with this study is online and on the webinar and can correct me or tell me if this is correct, I'd appreciate it. But my understanding is you've got all these different kinds of households with different options, and so it's looking at, well, what are the decisions that they're making? Which cars are they driving, and how do you and how long are they driving them? Because I believe it's actually also looking at the VMT. So it's like, it's kind of getting to that question, right? You know, this household that has the fuel cell, are they typically driving more than the household that only has gasoline vehicles or has a gasoline and a hybrid only, right? So again, if there's anybody on the phone from Davis who could make sure that's correct, but that's my understanding of the study. So in a couple years, we might have some data, enough data to be able to look at some of those answers. But yeah, anecdotally, absolutely.
This is Jane with the Energy Commission. So I've been trying to think if I think the route assignment methodology is a problem. I don't think I've come up with anything better than going with the fastest supposed path, right?
Okay.
That's you're using now, right?
Yeah.
Yeah. And that would seem like, yes, that's why there's more trips on the high-class roads that have faster speed limits. Even then congestion, they're likely to go faster. You know, but really we don't know the real path, and we know a lot of people trip chain and they drop the kid off at school before work and they pick up food on the way home and they do all these things, so there's so much uncertainty about the actual pathway. is there any chance of maybe putting more weight, like when they get closer to the destination, you know they end up there? I was wondering, like, if that was one idea that just came to mind, of if there's some, and maybe it's also nicer for people to fuel when they're nearer to that destination as well, rather than, you know, stopping in the middle. I don't know. I'm just trying to think if there's a better way to kind of get closer to that,
So
where people really might be more likely to.
yeah, I'm in the data that are stored right now. I don't think yet, like, it's not something I can just like click a few buttons. But if I'm thinking about it, I think if we generate, I think we might be able to generate a certain number of, I guess you could call them ancillary data sets that would kind of be like, okay, well, this is a distance along this path relative to the full path, which then we could then overlay in addition to adding the factor of how intense the early adopter market is at the home base of that path. So yeah, we could do something like that. I think we could do it. I'm only hesitating because I haven't done it, and I think it's not necessarily just like one step. I think it's a few steps to get there. But I think it could be done.
Well, I was also wondering if that might result in kind of more clustering again, like
right.
People are ending up, I mean, it's where probably where our, you know, work cluster, where our office clusters are.
Right.
But maybe that, I don't know, maybe that
it might help
a picture that would.
It might help limit how far out some of those, if we include it as part of the market assessment too, right? It would help limit how far out some of those, like, you know, little branches, right, that were coming off of the core markets actually extend, right? Because if the further, or I guess you really want to do it based on the closer you get to the middle, the less, right?
Right.
Yeah, maybe. We'd have to figure out, do we want to actually go all the way to zero, or we'd have to figure out kind of what's that cutoff amount, right? So there's a lot, I think there's a lot of questions that have to be answered. I'll say I don't think it's technically impossible. I think we'd have to spend some time on it.
Yeah. And I was just thinking too, like, I do kind of wonder that if it does become too tempting to be too prescriptive when we put too much focus on being close to the high-capacity roads. I mean, in some ways it seems totally logical that, yes, if all these cars are traveling there, I mean, whoever they are, there's a good chance that at least more people are passing that point.
Right.
But is it really the early market folks, and is it really places where they want to stop? I mean, these are questions we'll probably never be able to really answer, but, you know, is there anything that gets us closer to it?
Yeah.
Andrew, this is Lance. I was thinking about that a little bit, about how we do the scoring, how do you include the roads, and there's been, I think UC Davis has done a good bit of study in the past on people refuel either near home or near work, and agree they usually don't stop mid-trip. It's usually on one end or the other of that trip. Right. Maybe the road analysis, assuming we think the data is okay and we can kind of pare it down to where the early adopters are driving, maybe that's an additional area that's applicable for those regions, as opposed to, you know, this is better or worse, but it just adds, in addition to the around the neighborhood, it adds another location that's potentially a forestation location.
Right. So if you can, well, I guess I can go back to it on the slide. You're kind of saying that we'd still say that basically, you know, the core markets themselves are really the area that we're interested in, but like the difference between this and the additional pieces that are sticking out are kind of like just an extra, like, hey, if you also, this might be something else. I mean, I'm not really sure how to implement it yet, but
if you end up, like you say, little pieces that are extensions of that, because a big group of them travel this route, end up in work destinations over here, it's an expansion of that general area.
Right. Yeah, and that's kind of what I was trying to get to with this, is that maybe what we do is we just still do the market as we've always done the market, and then but we also look at, well, what's the market if we include the travel patterns and take the difference, and then maybe that's what is that could be the connector, or the, you know, the travel factor or something, right? You know, that's another possible implementation of it, right?
Yep.
So this is Jean from the Energy Commission. So Lance, are you envisioning scoring, numerical scoring? So you know we have the CHIT scores, we have CHIT values for coverage and capacity, and then we have coverage and capacity. So you know about those. So you're saying add a third, which is the traffic pattern, but it's weighted a little less than the first two. Is that how you're envisioning it, that you'd be comfortable?
I think I was more thinking that you have a region that's defined currently by proximity to only their home location, and knowing the travel path and work location opens up a broader area that could be defined as serving that demographic group. So it wouldn't necessarily be a traffic-based one. It's just, in addition to near the home, there's this corridor road and a cluster, if there's a lot of people that go to that work location, that's now all part of that. Station Anywhere in here will help serve that customer group.
So this is Phil. So going along those lines, is there any data, or have you looked at where those high wage earners do work? And is that a different cluster? I mean, it's probably different than where they live, but is that something that could be defined, since you know, well, I don't know, do we know both ends of their commute?
We know the end point of each commute.
And so if they're leaving from a high value area, is there a cluster of them all going to work in a similar, you know, do they all go to Wall Street, or,
yeah,
you know, and they're all able to afford that car, they're more likely to refuel in that neighborhood, even though it may not be a residential, may not be captured on the residential demographic, but on the work end of their commute, that's where they're going to park and eat lunch and refuel.
Right. Yeah, we could, yeah, I mean, we're basically trying to look at what we could do is just look at the clustering of endpoints for after we, on either end really, well, we already have the early adopter home end, so.
Right. Yeah, would that tell us
work
something?
Market evaluation.
I mean, you could be stereotypic and say, well, okay, if they're going to the Apple neighborhood to work, they can probably afford this car. But
right.
If we really have some of that data
right.
to look at, you know, which business parks or which parts of town are these high-value jobs connected to the neighborhoods they come from.
Yeah. Yeah, we can look at that. We could try and see what we can learn from that. I'm trying to think of what might be concerns in there. Mostly based on what I had mentioned earlier about the limits of the resolution too, right? Because we have like the census block is the limit of the resolution, and you know, you might have a high-powered, high-value company in that block, but a whole bunch of, you know, little mom and pop, you know, restaurants, right? You know that, and conversely, thinking of the resolution of the data we have for financial indicators and all that, that's also block group, and that's at block group and zip code level. So, you know, you could have, on the other side, you could still be in a high early adopter you still have people who are in high early adopter metric areas who are not early adopters, right? The early adopter metric is just kind of the proportion, sort of, right? So I think we might run the risk of essentially we're also lumping in people who just happen to be working and living in those same places who aren't really, right? But I'm not sure how we would. I'm not sure if we're not doing that anyways, and I'm not sure if we're not how we would avoid that. So I'm trying to mentally run through whether or not that's an issue, but maybe that's something I got to think about over some time. All right. Are there any other comments or questions before we wrap up?
This is Lance. We've kind of talked about the core markets and travel. I think you also were asking about the connector station piece and the broader elements. I'm not sure that the commute data is giving us a lot, especially on the farther away connector stations. I kind of feel like the data you showed made sense, but it mostly made sense because, yep, those are population centers as opposed to because of the commute data.
Right. Yeah.
Or maybe you could say the commute data helped you confirm that those were population centers, but that's really all it did.
Right. Yeah.
Sebastian Serrato, Energy Commission. Andrew, I think that I remember someone earlier was speaking about splitting up the data, and like we have now is we have our 2D view, maybe have a 3D view. And I think that might help with sorting out those different metrics that we're using to define where we're placing our stations, because right now it's just, I'm not sure if it was mentioned earlier, but having just one score that we look at may hide, most likely will hide some of the things that we're concerned about. So maybe having these different dimensional views will help a score team to really try to pick out the complexity.
Okay.
Thank you.
Yeah. All right. Oh, is there one online?
Okay, we just got a question online just in the nick of time. In terms of timing, how much time would you need to implement this potentially new metric?
So, yeah, I have to go back and kind of figure out. So if we do just kind of weighting the paths based on their home-based early adopter metric, I don't think that's too intense. We would have to redo this 3-week process of adding everything back up into, we don't have to redo the full 6 months of simulation, but, oh man, this part where we had the 760 different files and then overlay them with our analysis grid, yeah, we'd have to redo that, because basically what we did in this step is we just essentially we counted up the number of commuters, right, along each path, and so you have 10 paths that cross each, say 10 paths, for example, that cross each cell. You have to add up the number of commuters on each path in that cell, and now what we're doing is we're saying we want to actually weight each of those commuters according to how likely they are to be a first adopter. So we'd have to do this. So that might, let's say it takes 6 weeks, maybe, 3 weeks of development to make sure we have the data properly in place to do that, and then 3 weeks to rerun it. So we could probably do that in the next month to month and a half. The idea that Jane had brought up of utilizing kind of trying to make the path value less towards the center and more towards the edges, I think that would be a few months of work, just because we have to develop more kind of pseudo data about the routes themselves to then overlay on the routes again. And again, we'd have to redo this 3-week process. Trying to think of some of the other ideas. I mean, anything that's utilizing just the traffic data as it is, right, is ready to go. So this concept of maybe, traffic data is the third dimension in the analysis that the Energy Commission does for scoring, that in a future GFO, that could, depending on how we want to, weight it. I mean, it could be done as soon as we do this weighting, right? It's just available already, right? This early adopter metric weighting of every route, or if we then want to wait also for the kind of fading in, I'll call it, right? The fade on the route. So that would be, I think, ready to go from what I'm hearing. The only other thing that might take a little bit of processing, but I don't think it would take long, is the idea where we also correlate the hotspots of traffic with the locations of gas stations, or the proximity of gas stations and density of gas stations along those hotspots. I don't think that would take long, maybe a couple weeks beyond that. But easily, if we're talking about doing all of these things, that easily takes us through to the end of the year, I think, in terms of what's available. I would say, I know earlier I said we might not have it in time for June, but maybe we could if we're able to get working on it really fast, is having the early adopter metric weighting on each path. I think probably by June, our June analysis, we could have that available. But the other pieces beyond that, I think we would not. And from what I'm understanding so far, or one of my takeaways, I just want to make sure that explicitly stated, is that it seems like for heat maps themselves, or coverage gap maps themselves, we're not looking to include the traffic as part of the market the way that we had on that one slide, right? We're looking really to use it as a separate metric completely. We're not really looking to have it included in the coverage gap kind of analysis. Right.
Yeah, this is Jean. I don't know yet because of what Lance was saying. It's kind of like an extension of this highly desirable area. It kind of brings it out a little bit more. I think that's what you were saying, Lance. Still could be implemented.
The other option that I guess is maybe the marriage of the two, is that we run it one way without traffic at all. We run it one way with traffic, and we see what the differences are. Our main, like Lance was saying, our main recommendation is still, here's the core market based on without traffic. But then once we add traffic, here's maybe some extra, and I don't know what we would do in terms of scoring. I don't know if maybe that's a second tier or something, but at least we're talking about those areas, right? We're identifying those and having some discussion, and maybe that discussion will lead us to what we need to do about those areas, but in terms of scoring. But at least to have the information available, I think, is part of the point, right?
Yeah, Andrew, I think it's interesting stuff, but I think you're still early enough in the analysis that probably it's not worth saying, oh, we're going to include it, until there's been further review and kind of look at what can be done with it. So keeping it conceptually separate for the time being makes sense, I think.
Right.
Yeah, this is Phil, so I'm kind of with Lance. I don't want to see it skew what we already have, because I think that's helpful. But if it can add something to it, then we can try it, see if it's useful, and if it's just extraneous information, then we'll try something else.
Okay. Yeah, on the line or online.
Just a comment from that person who had the timing question. The background of the question is that it takes some time to identify and secure stations. I already work on future site selection, and they're apologizing because it's late in Paris at this time.
Oh, right. So, I mean, we'll work as fast as we can. I think also keep in mind, if you are interested in site selection as it pertains to potential GFO funding, I mean, we're also limited by the cycle of when the next GFO comes out, and our analysis comes out in June for the June report. So I think that's a key milestone is the next June report, and then and then also whenever the next GFO comes out. I think those are the milestones to keep in mind and to track. I understand business probably moves a bit faster, but right, at least if that's your concern, is the GFO, just keep an eye on that, and we'll try and do our best to get as much as we can into there.
Okay, and with that, I'd like to thank all of our participants for their fabulous questions, and thanks for all the input, and thanks to Dr. Andrew Martinez for the presentation. And it's 4 o'clock on a Friday, so I wish everyone well.
enjoy your weekend, everybody. Thanks, everybody.